Can we turn a spool of plastic into a working model train switch? Let's find out as we design, 3D print, and assemble a custom turnout from scratch. We're going to assemble the curved turnout. It has to be printed in two parts because it's too big for my printer bed, so we're going to super glue them together. And I'm just assembling them on a piece of cling wrap because it's polyethylene and nothing sticks to polyethylene. We'll be able to get this stuck together and not stuck to the table or anything else. Make sure they're straight. That should be stuck together now. There we go. We're going to measure out and cut all of the rails. So there's 2 switch rails, 2 wing rails, the frog point rails, and the stock rails. So essentially what we're going to do is roughly measure out where they go, mark them, and then go cut them. And we are back with our parts. And that one goes there. And these will have to be trimmed, but they'll go here. And they get some filing on the ends. There we go. Now I'll cut the rest of them. We'll come back and then we'll keep going with the assembly. We have all our parts cut. We've got our switch rails, our stock rails, our frog points, and our wing rails. Now we're going to start by shaping the stock rails, giving a slight curve. It would be nice if I had a tool, but I've just got thumbs and fingers. It's a delicate balance between curving it and not kinking it. It gets threaded through these spikes. A little protrusion right here where they were glued together. There. Now this will get threaded through, and what I'm going to do now that it's on, it's got some, make sure we can see it. We've got some excess on each side. I'm going to mark the first, last tie, and we're going to mark where it needs to be clearance. So just on the other side of the switch ties, I think it was 8, 2, 3, 4, 5, 6, 7, 8. So we'll clearance the rails. I'll do that for the same for the outside one, or I guess the inside of the curve. And that'll be the next step. We'll clearance these out. And that was a issue I ran into, is I got in a hurry, glued these in without doing that, and then I had to try to come in here with a Dremel and clearance that rail for the switch for the point rails. It was not fun. So here it is with all of the rails in place to be marked. Got the switch points, got the frog points, wings, and the stock rails. Stock rails are marked. I need to mark the switch rails. 1, 2, 3, 4, there's 5. 1, 2, 3, 4, 5. So those need to be clearanced on the outside, those on the inside. And these need to be ground down through some fixtures that I made that hold it at approximately the right angle, so we file them down flush to that, and they should match. So I'm going to go take these to the grinder, grind them down, come back. We can show some of this filing because I can just do it here at the bench, and we'll get on to assembly. Filing the frog points. So we insert the rail into this little jig until it sticks out fully, right? So we can get the whole top of the rail head narrowed down, and then we just start filing. A lot of filing. There. Deburr the edge. And we got it down to a pretty sharp point. So this can slide in. And now we repeat that with the other side in the other jig. The frog rails are filed down. Now we're going to start pushing them into the frog point. Now there isn't much guidance in here, mostly because, oops, and that's the tough part, getting everything to sit in there so it can all jam into place. I do have like a little wedge piece here that guides the switch rails in, but in the frog area, the gap between the flanges of the rails is only about 0.025 millimeters, which is not something big enough to print. Now the critical thing is the bases can't ride over each other. And we'll put our switch rails in. Oh, forget happened to me. In addition to clearancing the rails, we need to remove the spike heads, and before we do that, we need to glue it in. I'm going to glue it on the outside. I'm just putting a drop at each tie, kind of at the joint between the tie, spike, and the rail. And then we can snip these off. And we're going to take our file, if I can find it, and sand this down. I want this nice and smooth so there's nothing for the switch rails to catch on. Now we can install these rails. There we go. All the rails are in. It's time to check clearances. So that's pretty good. So we are going to glue this stuff into place. The outside curve always winds up okay. This one needs a little help. Let's run a truck through it and see. Yeah, that's a little rough. So it needs a little helping in there. Glue the frog rails in place. Oh, that wasn't, I did that wrong. You always want to glue them on the outside so if you do get anything out of place, it won't mess up the flangeway where the wheels ride. So on our switch tie, we have to cut off the outside There we go. We've got to cut off the outside spikes. A little glue. And I want to make sure we don't have too much on there. Oh. Ha ha ha. So let's get that off of there. It's my kit and I forgot how to build it. So we have to cut away the tie joiner on the bottom. I don't know what you call this. there's a section of plastic that runs along, joins all the ties for printing to keep everything together until you put the rails in. Close it together, make sure this is there. I'll give it a little, ooh, that was a lot. I'll give it a lot of shot of accelerant. I don't know how I got these so crooked. I tried to save the last one, the best one, for last once I figured out how to do everything, and I screw it up. This one doesn't roll very far without a good hard shove. And we can use the metal wheels. Slides through. Switch it to the other side. There we go. Okay, so now what we need to do is drill a hole for the ground throws, because that's what I'm going to try to use for this. I kind of want them at the end, and unfortunately they do not glue. Whatever they're made out of, it's either polyethylene or polypropylene. Very stupid. Now these look ingenious. These are Caboose Industries ground throws, and they're a neat design. Apparently they've got some sort of spring inside to give them over travel features, so it accommodates different travels, but you can't glue them to anything, so they have to be literally screwed down. That should fit in there. So once we put them on the layout and can screw them down, should work. So now we've got to cut some gaps in here. The frog has to be cut and isolated because there are conditions where you can have a single wheel touching both rails, both sides, which will short it out. And this is very tricky. I am using the coping, or not a coping saw, a fretting saw. Per the, this is delicate operation. So this is taken, the advice to use the fretting saw is taken from the Fast Tracks how-tos, tutorials, whatever you want to call them, how to use their jigs, and I agree with them. This is the way to cut the gaps. I've got a die grinder over on the bench with a cutoff saw, but that has the danger of cutting into the rails you don't want to cut, and it's a pretty wide gap. And I put it through the wrong slot. Okay, this one. Double fit. Nope, do the wrong one again. This one. There we go. Now I got to redo it all again. Good thing. Yeah, I knew I would need more than one blade. I'm glad they gave me like 20 in a package. This is like a 7-hand operation to get this done. Okay, let's lean that up against there. Let's stick this in here. Pull it as taut as we can by hand. Anybody has a trick on how to get these slotted through there and tight, let me know. This is a lot of work. Okay, but now it's in. And we're going to cut our gap. And there we go. So we got gap cut across the frog. We have a hole cut for our
switch machine.
So now we're going to add in wiring. We need to power the frog for one, and then I want to make sure out here at the end the rails are powered and we're not relying on switch points to bring the power. So here's one I've already done. I'll use this as a pattern. So let's do these first. What we need, a piece of wire to go from here to here, a piece to go from there to there. I'm using magnet wire because it's nice and small. I did one with some like 20 gauge coated wire, and it fills up the whole gap between the ties and doesn't look good. Tinning these, putting a blob of solder on the rail, and melting that and sticking the wire into it. Take our wire, multimeter, 0.5, that's about as low as it goes. So we'll call that good. Now I'll jump over to the frog, because the rest of these are all the same. Flux in there. Flux there. Apply some heat. Now, let's see if we got any kind of a connection there. That's good. So there we go. We're going to connect these two rails, that and that. And we'll be done.
Now that we've built a turnout, we'll go over how it was designed. Let's start by taking a look at the parts of a turnout. We've got the stock rails, the point rails, which are the parts that move and change the route of the train, the frog, where the two routes are split, the wing rails, and the guard rails, which guide the wheels and make sure they stay on the right route through the frog. Now that we know the parts of a turnout, we need some dimensions to put them all together, and the best place to get those is the NMRA. We're building ours in HO scale, so we'll look at that line on this chart. The things we need to know are the gauge at the frog, the flangeway, which is the clearance between the wing rail and the frog, the check gauge, which is distance from the frog to the clearance side of the guardrail, the span, the distance between the clearance sides of the wing and guardrails, the points, which is the distance between the gauge side of the points and the clearance side, and determines the clearance for the wheel flanges, and H, the minimum vertical clearance at the frog for the wheel flanges. Last, we need to measure the rails we're using and the track the turnouts will connect to. We need to measure the height of the rail, the width of the rail head, the width of the base, and these two dimensions on the base. We also need to measure the mating track, the height from the bottom of the ties to the top of the rail, so we can make sure there's no height difference between our turnouts and the rest of the track. Now that we have all those dimensions, the first thing we create is the spike head module. It needs to contain the base of the rail and be printable, which means not too much of an overhang. We wanted minimal clearance. I used 0.08 millimeters between the rail and the spike module, and that worked out pretty well. I also made it place the bottom of the rail at the right height to make sure it mates with the rest of the track. This can be as detailed as you want. You could make the spike head round, you can make it the scale size, you could add the tie plate and all sorts of details. Because I'm working with mating to Atlas Code 100 Flex Track, and I'm on a tight time schedule, and this is the first time I'm doing it and I want it to be robust, I just went with a very big but robust spike head. So once we have the sketch, we extrude it, then we mirror it, and we have our base module that is going to hold the track in place to create our turnout. At this point, you'll want to print one out as a test, check the fit, and change it if needed. Track works on gauge, which is the distance between the insides of the railheads. Because the track works on gauge, but the radius of the curve is measured from the center of the curve to the center of the track, we have to know whether we're measuring to the outside of the rail or to the inside of the rail from the center of the curve. For me, the best way to keep track of this was to make a chart, so I didn't have to do the math while I was drawing the track. I could just draw the center line of the rail using the numbers from the chart. Now we'll draw the rail center lines. It starts with the frog. Everything builds off that. The frog is a right triangle, and the ratio of the long leg to the short leg is the number of the turnout, in this case, a number 8. So the long leg is 8 times the length of the short leg. we need to figure out the center of the curves. We start by drawing circles for the 20-inch radius outside rail and the 24-inch radius inside rail from the frog point because we know they cross here. Next, we make lines parallel to the frog lines at those distances away from the frog. Line and circle cross is the center of that curve. Now we draw 4 circles, 2 from each center, and dimension them for the inside and outside rail of each radius. We need to trim the excess track, starting with the split side of the turnout. The important thing is fitting 2 pieces of the flex track we're using to the ends without them interfering. The flex track we are using measures a little more than 5 millimeters from the rail center to the edge of the tie, so we will use 6 millimeters for clearance. We draw a circle 6 millimeters larger than the outer 20-inch radius and one 6 millimeters smaller than the inner 24-inch radius. Where these two cross is where we want to cut the turnout. We draw a line from the center across each of the rails. We draw a line from the 24-inch center across the other end of the turnout to mark where it'll be cut on that end. Now we can cut the rails. We can also delete the lines used for construction. One set of the rails must be cut before the points. We want a 24-inch radius turnout with a 20-inch radius diverging from it, so we cut those rails. Here we are, we've got the rail center lines drawn. Now we need to draw the wing rails. We'll draw some more circles, set them to the right dimension from our chart. Okay, now we look at wing rail length. So I'm just going to draw a line and give it the right dimension from our chart. Now we trim them where they meet the point rails and where they meet our cutoff line. We can delete the rest of the wing rail circles. Then we'll trim our lines here, and there we go. We've got the wing rails laid out. The last thing we need are the guardrails. Same thing. We draw 2 circles and set them to the correct dimensions. Now we're going to need another construction line to cut these off. So we'll do that. And we'll dimension it from the point. Now we've got one end. And we trim those. Now we need to get the other end. So we'll just draw another construction line, dimension that. From here to here should be 19.25. There, we trim those, and we can go find the rest of those lines, clean them up. Now we need to draw the guards, and these are very shallowly angled in the spec. I'll probably do them a little steeper than they are. They've only got an offset of like 0.5 millimeter from the guard main portion. Okay, then they need a length, and it's 9.6. So these can just be adjusted by eye. If you're really a stickler, you could create some lines and get them exactly to spec, but they'll serve their function just fine by eyeballing them. Okay, so that is our drawing. So there are the center lines of the rails. This is probably a little long, but it'll do for now. In general, we're going to make a pattern along a path using our spike head module and our rail center lines. In FreeCAD, we make a copy of our spike head module, select the module, then the line we want to use as the path, and from the drafting workbench, select pattern along path. We have to make it aligned and force it vertical, then set the number. Based on the spacing on the mating track, there are 45 ties along the outermost rail. Then we repeat that for each rail, counting and adjusting the number of spike modules to match as best as possible. The wing rails are next. This is a little different. We make a new body, copy and paste the rail center line sketch and the rail profile sketch into it. Then we select the rail profile and map mode, which allows us to easily relocate it to the end of one of the wing rail lines. Then we select that rail outline and all of the wing rail lines, then additive pipe. We repeat that for the other wing rail, then we save the file and export as an STL. We import the file into Blender where it's a bit easier to create the ties. We add a plane, scale it to the right width, give it plenty of length, then extrude it to the proper height, in this case 1.61 millimeters. We check to make sure the bottom is flush with the bottom of the spike module and the top is flush with the top surface. We hit Shift D to duplicate it, scale it on the Y-axis to a good length, rotate it, and position it. Then we hit Shift D and repeat, rotating as required. Eventually we will need to lengthen the tie, so we rotate it straight, scale it along that axis, and position it. We're going to start getting rid of the excess spikes. With X-ray mode on, we edit the turnout object and delete the spikes we don't need. Some of the spikes don't line up exactly. To fix this, we increase the width of the tie to cover all of them. Ideally, we would offset the spikes along the curve to get them to line up better, but I don't know how to do this in FreeCAD, and Blender doesn't have true curves, just a bunch of straight lines. So I chose accurate curves over visually appealing spike placement, as function is more important than appearance in this application. The spikes are joined with the ties. The next step is joining the ties together. We do this with a cube, placing it under where the rails will go on one end, turning on the edit mode, and extruding it along the turnout. Repeat for the other side, frog, and point rails. Make sure the bottom of these are flush with the bottom of the rails. The excess spikes need to be deleted by removing all the nodes above the surface of the ties. This is a little tedious, so we won't show it, but here are the final results. We also made some aligning wedges by extruding the edges of the removed spikes that guide the rail, then joining them together. This helps align the rails where the spike heads had to be removed. Almost forgot this. This is how I made the jigs to file the frog points. I started by taking the rail profile we had before that we used on the guardrails and ran it along the rail center lines for the frog points just like we did with the spike modules. Then I exported those two as STLs. We import them into Blender. The first thing we're going to want to do is to modify them because we've got essentially the tie thickness on the bottom. So we go in here, grab those, and we move them up to thickness of the tie, 1.61 millimeters. Then we do the same thing to this one. There, now we've got our two rails in. And I just did this by eyeball. So if it's a little hard to see, but if we make everything a wireframe, we can add a cube. Let's scale it up a little bit. There. And now we'll make it a little bit longer on the x-axis. Now what I did is just position it by eye. Oop, I don't want to flip that upside down. So if we look in here, we want it, essentially the two rails meet at the origin, and then you can see where they separate here. So we need to rotate it a bit and grab it. And that is actually pretty close right there. So now we've got it at the right angle. We grab it on the x-axis and move it until the rail flange peaks up. Actually, we can move it down a little bit too. There, now we make sure it's got enough so that it sticks in here. Oop, I don't want to do that. Now, while we've got this cube selected, we go to modifiers, we add a modifier, generate, Boolean, right? And we want to do the difference because we're going to subtract this rail from this cube. You can click the eyedropper, click on the rail, and apply. And let's just make it back to normal so we can see it. Now it doesn't look like much happened, but if we hide the two rails, we can see that there's now a hole through there. And that's how I made the jig. So you take the frog rail, you thread it in from this side. I didn't get this centered right, but obviously if you take a little more time and care rather than just trying to show it quickly, you thread the rail in, stick it out until the base is here, file it down smooth, and that will give you the right rail. And obviously you repeat that for the other side, and you've got your jigs. So were we successful turning a spool of plastic into a working model train switch? Yes, we were. If you enjoyed this video, here's another one you might like.